Good morning, students. So I am Gopal, head of the Department of Humanities and Science. So in this class we shall discuss values of how to find the values of the logarithms. So last class we have to see the properties of the logarithms. Yeah. Now there is one example. Find the value of log 343 to the base 7. Okay. Now we have to find out the value of this logarithm by using the properties. Now given that log 343 to the base 7. So this 343 can be written as 7 power 3 to the base 7. Okay. So therefore here 7 into 7 into 7. So this is 49 into 7. This is becomes 343. So that's why we have to written. So this 343 7 to the power of 3. So we know that one of the property log m to the power of n to the base a. So this is equal to n log m to the base a. So this is the one of the property. By using this property, this is log m to the power of n to the base a. So therefore, it can be written as 3 log 7 to the base 7. So we know that one of the property. So that is, now since log a to the base a means if any logarithm to the base, same base, that value equal to 1. So by this property, so this log 7 to the base 7 is becomes to 1. So finally this is equal to 3. The log 343 to the base 7 equal to 3. This is the process of finding the values of the logarithms. The next example, find the value of log 625 to the base 5. Yeah, given that log 625 to the base 5. Now this is equal to, so 5 5s are, now this is 25. 25 5s are, this is into 5 means this is 125. So 125 5s are, so it becomes 625. So therefore this 625 can be written as 1 2 3 4 5 to the power of 4. So here we have to written log 5 to the power of 4 to the base 5. Clear? Now 625, this 625 can be written as 5 to the power of 4. And now this is equal to 4. Now this 5 log 5 to the power of 4 to the base 5 equal to 4 times of log 5 to the base 5. Here we use, so log m to the power of n to the base a equal to n log m to the base a. We use this property here. And similarly here we have to one more formula, that is log a to the base a means if any logarithm to the same base, that value equal to 1. So therefore by using that property, this value is becomes to 1. So finally the given logarithm 625 to the base 5, this value equal to 4. Just read the next example. Find the value of log 256 to the base 4. Yes, now given logarithm is log 256 to the base 4. So here 4 4s are 64, 64 4s are, so this is equal to, so 256. Fine. So therefore this 4 cube means this is 256. So therefore log 4 cube to the base 4. So finally this is 3 log 4 to the base 4. Now since log m to the power of n to the base a equal to n log m to the base a, and the next one, so if any logarithm to the same base, that value equal to 1, so therefore this is equal to 3. So this is the process of finding the given logarithmic values. Now students, now we have to discuss the two important things here. Now note one, if a, b, n are positive real numbers, b not equal to 1. So then log a to the base b power n. So in similar means the last cases we have the logarithm this type, m to the power of n to the base a and log m to the base a. And similarly here log a to the base b to the power of n. This is equal to 1 by n log a to the base b. So this is the important note. And similarly we have the one more note. If a, b, m, n are positive real numbers and b not equal to 1, the logarithm is in the form of log a to the power of m to the base b to the power of n, and this value equal to m by n. So here so we multiplying by one constant. The constant is form m by n, means a to the power of m can be written here in the numerator and b power can be written in denominator. So therefore m by n log a to the base b. So these are the two more properties of the logarithms. So students, remember these two logarithms. So this is a very important properties. Now students, now this is the next example. Find the value of log 5 to the base 125. So now solution. Now given that log 5 to the base 125. So here the base can be expressed the powers of 5. So therefore this is equal to log 5. Now this is 5 5s are 25, 25 5s are 125. So therefore 5 cube. This 125 can be expressed 5 power 3. Yeah, now we know that one of the means property, log a to the base b to the power of n equal to 1 by n log a to the base b. So by using this property, this logarithm can be written as 1 by n. What is n here? N equal to 3. 1 by 3 log 5 to the base 5. And this is equal to 1 by 3 of 1. Why? Because now since log a to the base a, this is equal to 1. So finally this value equal to 1 by 3. So this is the process of finding these kind of logarithm values. Now students, now we have to find out this logarithm value. Now given that log 128 to the base 8. So students, please now recall, means observe the previous problems. Here base is 8. Either this 128 can be expressed the powers of 8, or this 8 is expressed this 128 powers. So here 8 we cannot express 128 the powers of 8. So therefore we have to return this 128 equal to 2 2s are 4. So this 128 can be written as 2 into 2 into 2. So means this is 4, 8, 32, 64, 128 means, so this is 2 to the power of 6. 8 can be written as 2 to the power of 3. So therefore it can be expressed, so 2 to the power of 6, 2 to the power of 3. So therefore this is equal to 6 by 3 log 2 to the base 2. Now since log a to the power of m, b to the power of n equal to m by n log a to the base a. And so finally this is, so 2 of 1 means, now since log a to the base a equal to 1. So finally this value equal to 2. So this is the process of finding these kind of logarithmic values. In the next example, find the value of log 1 by 81 to the base 3. Solution. Given that log 1 by 81 to the base 3, and this is log 1 by this 81 can be expressed 3 power 4. So 3 3s are 9, 9 3s are 27, 27 3s are 81. So therefore 3 to the power of 4 and to the base 3. And we shift this denominator into the numerator. So therefore it is becomes 3 to the power of minus 4 to the base 3. Right? So therefore this is equal to minus 4 log 3 to the base 3, and finally minus 4 of 1, this is equal to minus 4. How to get these values? Yes, here we use one of the property log m to the power of n to the base a. This is equal to n log m to the base a, and here we use log a to the base a. So this property, so finally we get this logarithm value equal to minus 4. Yeah, the question is find the value of log 49 to the base 343. Yes, now we have to find this value by using these steps. Log 49 to the base 343, and this 49 can be expressed 7 square. 49 7 7s are 49, and 343 equal to 7 7s are 49, 49 7s are 343. So therefore this is 7 square, this is 7 to the power of 3. So this is equal to 2 by 3 log 7 to the base 7. Here we use this property log a to the power of m to the base b to the power of n equal to m by n log a to the base b. So this is the process of finding this logarithmic value. Here we use log a to the base a. So this property, so finally this value equal to 2 by 3. So these are the process, this is the process of finding the given logarithmic values. So dear students, here we use general properties. We have the 7 or 8 properties. By using that properties, we have to find out these kind of logarithmic values. Now I will return here assignments based on the previous problems. Now students, these are the assignments. So based on the previous problems. Now I will give the 4 assignment problems. First one, find the value of log 256 to the base 4. So this 256 can be expressed the powers of either 4 or powers of 2. Next, so this is log 243. So here, so this 243 can be expressed 3 power something. For example, 3 power x, and the square root is there. Square root can be written here 1 by 2. So finally we get 3x by 2. What is x? So this 243 can be expressed powers of 3. Okay. So next, now this is log 2 by 216 to the base 6. This 216 can be expressed the powers of 6. And finally this is log. So this 64 can be expressed the powers of 2, and this 2. So this 2 means this root 2 means 2 to the power of 1 by 2. Okay. So these are the some hints of this the given problems. Now students, now this is the today class. So next class we shall discuss some more problems based on the properties of the logarithms.